Okay, this is problem number 1 for the circles benchmark. The problem reads, the radius of circle H is 10 inches. Part A asks, what is the circumference of the circle? Okay, well, the circumference of the circumference is the distance around the circle, and if you don't remember the formula, we have it here on our reference sheet. It's c equals pi times d, d being the diameter, or c equals 2 pi r, where r is the radius. Now it tells us in the problem that the radius is 10. The radius of the circle is 10 inches. So c equals 2 pi r, circumference equals 2 times pi times the radius we know is 10. C equals 2 times 10 is 20 pi. So my circumference is 20 pi inches. And if you notice, sometimes we just like to, for ease, we like to keep our answer in terms of pi, which means we have it just in the answer. But what we know is that this is actually 20 times pi, or 20 times 3.14. So if I were to actually multiply the decimal out, 20 times 3.14 equals 62.8 inches. So the distance around a circle, around this circle, is 62.8 inches, or if we kept it in terms of pi, 20 pi inches. Okay, part B. Part B asks, what is the arc length of arc RS? Now, arc RS is, I'll highlight it in pink. That is arc RS. Now, in the videos, for the notes video, they stressed the part of circle over the whole circle. That's very important for this concept. So what part of the circle, what fraction of the circle is this arc? It's not the entire thing, clearly. It's only part of it. Well, the fraction that it is, it's 60 degrees. It's 60 degrees out of 360 degrees. That's the part, this arc, over the entire circle. So 60 degrees over 360, and on the other side of our proportion, the same ratio is the arc length over the circumference. And let's just think about a reasonable answer right now. The arc length of this pink arc, our RS, I mean, we know the entire distance around the circle, the circumference, is 62 inches. So do you think that the arc is going to be like close to 62? Is it going to be maybe close to 30, which is about half of that? Or is it going to be a lot less than that? And I actually think it's going to be a lot less than that, because it's not going to be half of 60, because our degree, our arc, is only 60 degrees. It's a lot less than half the circle. So when we rewrite our proportion, I'm going to say 60 over 360 equals, the arc length is x, because that's what I'm trying to find, over the circumference, which I found in part A, which is 20 pi. And I'm just going to keep it in terms of pi for the ease of multiplying. So now I cross multiply. I get 360 times x is 360x. 60 times 20 equals 1200 pi. 60 times 20 pi equals 1200 pi. I divide by the coefficient in front of x in order to get it by itself. So now I have x equals... Now, can I simplify this fraction? Well, let's think about this. What is the greatest common factor? What is the largest number that divides into both numbers? I think 120. So 1200 divided by 120 is 10. So I've got 10 pi on top. And 360 divided by 120 is 3. So this fraction right here simplifies to 10 pi over 3 inches. Or in other words, if I wanted to make a decimal out of it, I could do 10 times 3.14 equals, divided by 3 equals 10.5 inches. I rounded it to the nearest tenth. So the arc length of arc RS is 10.5 inches. And if you think about that, that's a reasonable estimate for the arc, given that the entire distance around the circle, which we calculated above, was 62.8 inches. Another kind of quicker way of doing this is if you realize 60 degrees is what fraction of the circle? 60 degrees actually is 1/6 of the circle. If you realize that, then you actually could have done, well, the distance around the entire circle is 62.8, so 62.8 divided by 6, because it's 1/6 of the circle, equals 10.5. Essentially, it's doing the same thing. It's going to get you the same answer, but we want to make sure you know how to set up the proportion for the part of a circle over the whole circle. Okay, let's move to part C. Part C asks, what is the area of the circle? Now in part C, the formula for the area of a circle, we know on our formula sheet, if you don't know off the top of your head, the formula for the area of the circle is pi r squared. So the area equals pi r squared. The area equals pi times the radius, which is 10 squared. Area equals pi times 100, or if I rearrange it as I typically do, 100 pi square inches. And our units of area are always square units, so because our measurements are in inches, our area units are square inches. If I multiply 100 times pi, or 100 times 3.14, I get 314 square inches. Okay, part D. Part D asks, what is the area of the 60-degree sector? Well, let me highlight in green here the sector. The green shaded area, that is a sector. So we're trying to find not the area of the entire circle, which we found, just the area of the sector, this slice of pizza or slice of pie, what I shaded green here. So again, we're going to set up the same ratio as we did before with arc length. It's part of circle, again from the notes, over the whole circle. Our fraction is 60 degrees over 360 degrees equals the sector area over the circle area. 60 over 360 equals the sector area, we don't know, we're trying to find, is x over the area of the circle, which we found in part C, is 100 pi. Now we're going to cross multiply, and actually what you can do to make the numbers even a little bit easier, you could simplify at this stage right now. You could recognize that 60 over 360 actually equals 1/6. So that would make your life easier when you're trying to solve the proportion for x. But we won't do that right now in case you forget to do that. So you're going to cross multiply. So 360 times x is 360x. 60 times 100 pi is 6,000 pi, divided by 360 in order to isolate the variable. We get x equals, now what is the greatest common factor in both 6,000 and 360? The greatest common factor is 120, so you're going to divide both the top and bottom by 320. So I'm going to simplify this fraction right here to 50 pi over 3 square inches. So the area of this sector, of this green piece of pie right here, is 50 pi over 3 square inches. If I want to make that into a decimal, I'm going to do 50 times 3.14 divided by 3 equals 52.3 square inches. That is the area of the sector. Now let's think about this. The area of the entire circle that we calculated up here was 314 square inches. Just like in the arc length problem, we know that this part of the pie is 1/6 of the pie. So what we could have done, essentially, was just do 314 divided by 6 equals, and 314 divided by 6 equals 52.3 square inches, which is the same answer that we got setting up and solving the proportion.